That is a part-built Rimac Nevera. This is a part-built Bugatti Tourbillon. This might be the world's most advanced car factory, and who better for a tour guide than Mate Rimac himself. Thank you very much for having us.
Absolutely.
Let's get stuck in. This brand new multi-billion euro spaceship is the Rimac Campus, just southwest of Zagreb in Croatia. It builds Rimac's own Nevera electric hypercars and houses the production line for prototype Bugatti Tourbillons. And with Porsche already using Rimac cells in the 911 GTS T-Hybrid, it's about to become the go-to battery birthplace for the world's household name car makers. So come along on a tour with Mate, a man who, despite being boss of Rimac and Bugatti, isn't afraid to lend a hand. Get this, because my dad will love this. You can't even dress yourself still. 33 years old, you can't dress. And still likes an immature joke. The bloody size of this place. It's enormous.
That's what she said.
We'll show you a naked Bugatti Tourbillon, a naked Rimac Nevera R, rooms filled with hundreds of millions of dollars worth of V16s, hundreds of millions of dollars of robots, mind-blowing tech, and have an exclusive poke around Mate's personal car collection. Let's start with a car you might not have been expecting to see here, the Bugatti Tourbillon. Mate is the Bugatti Big Cheese, and while production tourbillons will be built at the Molsheim Atelier in France, in keeping with Bugatti tradition, the prototypes are created in Croatia because the hybrid tech is coming from Rimac, and that needs to be taught how to speak English so it gets along with the British Cosworth engine. So, Tourbillon engine, when I've been to Molsheim and seen the old Chiron engine, it's enormous. It like fills the room. This looks so much more compact. You must be really proud of that.
Well, yeah, the Chiron engine was 450 kilos. This one is 250 kilos, so 200 kilos less just on the engine. Plus, you know, there is no intercoolers, there's less heat generation and stuff like that. But of course, you have the hybrid system, which adds up weight. But in the end, I don't know of any other car that's lighter as the hybrid successor than the combustion engine only predecessor.
Yeah, very true.
So this car is somewhat lighter than the Chiron. And this is really something I'm really proud of. Yeah. You know, very emotional V16, naturally aspirated, 1000 horsepower, high revving, 9,500 RPM, 8-speed double clutch gearbox, and the electric motor in the back. And as you can see, it's a tiny electric motor that's, yeah. So this can provide, you know, I mean, it depends on the battery, but the motor itself can provide like 500 horsepower, almost 400 kilowatts. And you can see that this difference in size between the big combustion engine and the electric motor. And then, of course, two electric motors in the front and the battery pack in the middle. The difference between the Chiron and this is Chiron used to have the gearbox in front of the engine. We now have the gearbox behind so that we can have the battery in the tunnel. Yeah. And then there is the monocoque with the two fuel tanks, the cabin, which is same dimensions like the Chiron for the passengers, but very different architecture. So it's a lot lower, and the passengers are closer.
You can see that that huge armrest kind of bulkhead you used to have is so much
it's
narrower now.
Exactly. So that we have a smaller frontal area. So, for example, I'll just give you one example. For me, it was very important to have a visible engine and open as much as possible, not like partially covered, no glass on top, and so on. And the engineers, the aerodynamicists, they really wanted to have a closed engine bay in order to improve the aerodynamics, to decrease resistance. But when we were comparing the Chiron aerodynamics with the Tourbillon aerodynamics, they were always looking at the drag. But the drag is just part of the story if you don't look at the frontal area. So by reducing the frontal area, we have a lower total drag, CV times CD, and therefore we could have some nice design elements, which are maybe a little bit worse in aerodynamics, but of course, you know, the car is not driving 400 plus kilometers per hour that often. So you want to optimize also for when the car has to be somewhere at low speeds and look beautiful.
Other Tourbillon highlights include aero-shaped suspension that's 45% lighter than the Chiron's, as it's 3D printed by Divergent offshoot Zinger in the USA. There are also Brembo's next-gen brakes, and the active rear wing is now electric, not hydraulically powered. But Matej's particularly proud of one item you'll hopefully never need in your multi-million quid hypercar, the Formula One derived crumple zone.
Right, so you wanted to come and look at this car. What was the secret you wanted to show us here?
So beautiful view on the V16, the high performance inverter for the electric motor in the back, and then the big exhaust system. But what you can't see now when you have the rear clamshell on is that the rear is very open. So usually you would have a big crash structure here, like in the Nevera or Chiron or basically any other car, you would have a big metal beam, aluminum or steel here. And you don't have that here. It's not because it's not mounted, it doesn't exist. Because this aluminum, 3D printed aluminum crash cone is the crash structure, but it's also part of the diffuser. So you have a very tall diffuser here, so you can go very high up with the diffuser, which means you can have it very long until the middle of the car, because the diffuser can't have any kind of angle. It has to be like 11 degrees is kind of maximum angle for the diffuser, otherwise the air starts to separate. So if you have a tall diffuser in the back, that means you have to have this 11-degree slope and it has to go all the way to the front. And as you notice, the engine is a lot more narrow than the W16. So we could have these diffuser channels left and right of the engine, plus we angled the engine. And this also means that the suspension is in the airflow. So you can see that the lower suspension arm is shaped like a wing because it's directly in the airflow. And this is only possible because this is also 3D printed. So you have lots of these little microstructures like you have here, also in the suspension arm to give it the stiffness while having this aerodynamic profile.
So there's sort of strengthening spars inside here?
Yeah, like little structures, just like this one. And you can see with the cone, like this is like thin here and it goes wider. So it absorbs more crash energy as the crash progresses, so that when it reaches the really stiff parts of the car, that already a lot of the energy is dispersed. And this, for example, we are doing with Aston Martin's Formula One team, this 3D printed part, and the 3D printed suspension, so lots of new stuff.
And if all that sounds very cutting edge, then there's also nods to old hypercar legends in here, like the McLaren F1.
Again, another noob question. The gold here, are we talking about gold foil in the engine bay?
Absolutely. And it's not just for the looks, it's because we actually need it. There's lots of heat happening right here in a very cramped space. There's lots of components in here, and gold is the best heat reflector.
And how many pounds worth of gold do you reckon you'll need per tourbillon?
Oh, that's a good question. I don't know. We're still looking at that because, as you see, there's some aluminum stuff in there, and I'm trying to change all of that to gold, but the designers are not too happy about it.
Trying to add more gold to the engine bay. Good. Keep it up. That's what we like. Yeah, it is a stunning engine bay, and it's great that it's been able to be kept open air.
And everything is real.
Like some sort of sea monster, I think.
Yeah.
This manifold here.
So and nothing is fake. Nothing is here just to be like to look like an engine and just to look like a cover. This is actually the engine intake. That's the real engine you see here.
Every time I thought Matej was about to run out of insane details to drool over, he came up with yet another innovation he wanted to show off. And it's not just stuff to do with the powertrain or the chassis. Even his new Bugatti's audio system is mind-blowing.
Also, one other thing, we don't have any speakers in the car. We use piezo elements that are vibrating the structure of the car, and the structure of the car becomes the speaker. So I'm not sure if you have one already put in here. Oh yeah, here, this is the base. So that's it, and we saved a lot of weight and space with that.
So that's effectively your subwoofer?
Yes.
But
yes.
it's tiny.
But that's not like it's...
Yeah.
So this would be like the magnet in your speaker, but this is the membrane of the speaker, the whole thing.
You're using the carbon tub to make your
the carbon tub,
music sound cool.
The door panels, and believe me, the sound quality of that car is in a different universe compared to the Chiron. So we saved weight, space, and improve the sound quality. And also comfort features like you wouldn't expect in a Bugatti. So we have here wireless charging pads, maybe millennial thing, maybe not important for a Bugatti, but we also want the Bugatti to be very daily usable. Yeah. Crazy performance, great to drive, but also daily usability.
I can't believe that this is on a hypercar. I thought like this would have been invented on a luxury saloon doing the speakers like that. That's very
You know what
cool.
we say? If we don't do it, who will? Yeah. If we don't do a crazy V16 or this hybrid powertrain or the 3D printed suspension or the sound system, even when I say it in my company here, when we talk about this stuff, and everyone is like, but Ferrari didn't do this or Mercedes didn't do it, like there must be a reason. I'm like, yeah, because nobody has done it, but someone has to be first. Someone has to try it out. It's like, Orazio Pagani, when he was in Lamborghini.
He was trying to convince them to use composites, right?
And they said, Ferrari doesn't have an autoclave. Why would we buy an autoclave? And he was like, you know what? I'm going to find my own company and I'm going to have an autoclave.
Yeah.
So that's, you
it's
have
where Lamborghini came from. It's where Pagani, yeah. A lot of these companies are set up by disgruntled people going, I can do this my own way. And I guess you're the modern version of that.
Leaving the engineers to carry on building their Tourbillon prototypes, I followed Mate through this automotive Willy Wonka factory to check out the very first customer build Nevera R. Listen carefully here to find out just how much the Nevera project actually cost and how the original idea for the first Bugatti-Rimac was to basically bolt an engine to the back of this car.
When you see it with its clothes off like this, what's amazing is unlike most other cars where you spot, like if it's a Volkswagen Group car, you see an Audi component or a Volkswagen component, everything is stamped Rimac. Absolutely everything is
There is not one piece that's from another car. It's actually one only component. It's this HVAC box that we heavily modify actually. This is from an Audi R8.
Even that's off a cool car, but everything else is you.
Yeah, we had to do everything. And for the Tourbillon as well, like when we started to develop the Tourbillon, we had many ideas in which direction to go. And actually the first concept of the Tourbillon that I did before I was involved with Bugatti was based on the Nevera. Like my idea was, the Tourbillon has 2 electric motors in the front. So I was like, okay, let's take the front of the Nevera. It has already the steering, the cooling, the crash structure, the brake system. So you can use all of that. And then it has a battery here. So you can use all of that for the hybrid system of the Tourbillon, and then cut the Nevera here and add a V16 here. But then you get into compromises and a Bugatti can't be like a Rimac and so on. And you learn, this was a 150 million euro learning exercise for me and the team. So you also learn a lot. So you don't want to, you want to use the opportunity to improve what you have learned. So Tourbillon in the end was completely ground up again. Maybe not the smartest business decision, but in the end it's the best product decision.
It's a car guy decision.
Exactly.
Zero compromise.
And I think that's what in the end makes sense. In the long run, the product is what matters. The product, if the product is great, then the company will do well.
Well, that's what will still be around long after we're all gone. The cars will still exist and people will still be writing about them and watching about them, and so you want to know that you didn't make any shortcuts.
Exactly. And we all know that electric cars are on a downward spiral at the moment. They are not being adapted by the market like everyone expected and so on. It's actually a crazy cycle. Like I remember, I'm not that old, but I feel like I'm a fossil in this industry because I started with electric cars 16 years ago. And at that time, everyone was like, what the hell are you doing? Why are you converting your BMW into an electric car? And nobody wanted to invest in electric cars. And then Tesla became successful and electric cars were all the rage. And then during COVID, electric cars went really big, huge growth. On the stock market, everyone was punished who didn't make an electric car. And then it went the other way around. So, it's the cycle, and I'm in multiple up and down cycles already, so it's difficult always to take a few steps back and think about what really makes sense. But now we are in this downward spiral, and so you have to look in the Nevera in that context. You started it at one point in time, it's now another point in time, and so on.
So if the demand for high-end EVs is so up and down, how many Neveras has Mate actually sold?
Of course, it's no secret that we didn't sell out all cars, but it's the most successful electric sports car. We have sold most of them, and performance-wise and technology-wise, it has been a game changer. Like when you drive this car, it's really on a different level. And it's different than a combustion car. Yes, it doesn't have V10 or V12 sound, but it offers you so many different things. But also for me personally, without the Nevera, there would be no Campus, there would be no Bugatti today, or no Bugatti Tourbillon at least. Yeah. So like all of this kind of led to where we are today. And this is for me a big part of the history, not just of our company, but also of the hypercar industry.
Yeah, you need these game changer moments. That often happens with cars that are needle movers. The McLaren F1 didn't sell brilliantly when it arrived. The BMW i3 or Honda Insight. You have these cars which people look back on and go, oh, that was a whole new path, but people kind of didn't buy it at the time.
I'm pretty convinced the Nevera will be like that, because the people who own it and drive it, they know how utterly, spaceship-like it is. Yeah. And it will take some time until more people realize it. But yeah, it did its job, and the Nevera R is now the next step. And as you saw with the car, it's really quite something to drive.
Yeah, it's wild. Right, let's go and have a look around.
Obviously, we needed to see a Nevera R with its clothes on, so here's a prototype they made earlier. Mate is convinced it will remain a speed record benchmark for years to come.
To be honest, I don't think that there will be anything that's going to beat it in some of its performance characteristics for quite a while, despite people thinking that in electric cars it's an arms race where every day there's something new coming. I think this will be on the top for quite a while.
I don't see anyone doing 0 to 300 kph in 8.6 seconds.
That's pretty crazy.
Cars like that don't come along very often.
Yeah, but that's just a number. But when you have something next to it that you think is really fast, that you think like, wow, this is a fast car, and then you launch this one, then you only realize what that means. It's like a huge difference.
And how it doesn't tail. That sensation when you get to like 50, 60 kph and the car almost goes, okay, now I've got full traction. And now I'm going to give you everything. And it almost seems to, the rate of acceleration increases.
Yes, it doesn't taper off.
I've never experienced that in a car before. Are you going to, given you've got this more downforce hungry, stickier tyre model, are you going to go after lap records? Does that interest you?
Well, we did a Nürburgring lap record. We did 27 world records with the Nevera. Yeah. I'm sure we'll do some others with this one.
Yeah, with this you can kind of go more and harder.
Yeah, but like we are boys, we like to compete, right?
Yeah, absolutely.
Still to come, Mate's car collection and the most Bugatti Tourbillons anywhere in the world. And if you missed our world exclusive drive of the record-breaking Nevera R, click the link in the description to watch that next. Anyway, that's the hypercars, but the Rimac Campus is so much more than just a speed machine dream factory. It's sort of like Silicon Valley, California and Supercar Valley, Italy, all rolled into one, and it's changing the face of Mate's homeland.
So the interesting thing about the Rimac Campus is at one side you can see people handcrafting carbon fiber pieces and leather upholstery of luxury seats and hand-making cars. And then in the same building you have a high volume production for super automated with like 80 robots just in this production line for making tens of thousands of batteries for other car companies. So this line is processing 50 million battery cells per year.
50 million? 50 million?
50 million battery cells. It's one battery pack every 10 minutes, one battery module every couple of minutes. So that rolls out of here from next year. So we are installing this production line. And this is a huge project for us. Lots of batteries will be made for different cars here. And the building itself is 120 million euros. And just this production line is 130 million euros, just this one production line. And there's multiple of these production lines here. So we are by far the biggest investor in Croatia and in the Croatian industry.
And what's next door? Well, one day this space will also build EV componentry, but right now it's the nerve center of Bugatti-Rimac's test fleet.
So we have lots of horsepower here, lots of Tourbillons, Neveras, Nevera Rs, and this is the proto workshop.
Yep.
So here we build XPs in a quick and dirty way. So this is not the proper process. Like this is more of like a real prototyping garage. And these are all the XPs that you see running around the world, like in Frozen Lake in Sweden or in Nardo. Or this car just came back from hot weather testing in Dubai. We were lucky to experience 50 degrees ambient temperature.
Wow. But then a lot of customers will, so you need to know it can deal with that.
So for us, it's really important that the car is super robust. So we already tested the X-Piece both in Sweden at like -20 and in Dubai at +50. I think it was even the same car because that car has all the instrumentation, like all the sensors for testing that. Then, you know, another car that's for suspension testing has other sensors and all the crash cars, interior box. So that's the kind of stuff we're building here. But another interesting thing about the Rimac Campus, which is just built, this is where a production line for another German car company for the battery pack will come. So we have to move this already out and tear down the walls and move stuff around, play the Tetris, because we don't have space in this huge facility anymore.
So it's brand new, and yet you've already got to move out and let the Germans move in.
Yeah, you know how they say, it's not the strongest one who survives, but that one most adaptable to change. And yeah, we have to change stuff.
Wow, this is one of the wildest rooms I've ever been in.
Lots of V16s lying around and batteries.
As you do.
Yeah.
Mate also wanted to show me around the existing battery facility, which the new campus will replace. And that meant jumping in his personal Nevera for a blast across town.
So we just have the camera pointing this way. We don't have a speedo.
No, there is nothing pointing at the speedo, mate.
Okay, that's good.
So.
Okay, I lied. This isn't a factory tour. It's the world's best science lesson with Professor Real-Life Tony Stark. Brace your minds to be blown once again as Mate delves into the differences in the Nevera and Tourbillon's batteries.
So this was the least bad option. This was like a DIY store, which was in terrible conditions. So we refurbished it as a temporary solution. But even now that campus is done, we still need all of that space, and we need more because the company has grown faster.
Yeah, so even though this was what you needed in 2021, this is now outdated, so to speak.
Yeah, so ancient for us is 4 years.
So what are we looking at in this room?
So here we produce lots of components and systems for other car companies, primarily batteries, but also powertrain systems. So here we have a few examples of what we can show, but most of the stuff we do here now we can't show because it's for other car companies. So we are very open with the stuff that we are doing. So I can show you everything about the Nevera, about the Bugatti and so on. But what we do for other car companies like BMW, Porsche and some others I can't say yet, I just can't show. Right. So here we have a few different battery packs and modules that are very different in their configuration and their performance. So Nevera, big battery pack,
yep.
Which is in this odd shape because usually for an electric car you would have a flat floor.
Yeah.
In Nevera we didn't want to have a flat floor because we wanted to have the seat low because if you put the seat on top of a battery pack, the roof goes up. Design is not that great for a hypercar, but also aerodynamics, frontal area is not good. So we have this odd shape where you have batteries under the feet, in the tunnel, and behind the seats.
This is good as well because it gives you that race car driving position where your backside's low but the feet come up.
Yeah, so it's also a challenge for ergonomics because we call this H point to heel point, so you don't want to have the heels too high.
Yeah.
But that's like what you have in Valkyrie or AMG 1 and so on. It's not as bad here. Still comfortable on long journeys, but primarily want to have the seat low. So that gets you this odd shape, which is more difficult from a battery perspective, but works from a vehicle perspective. And that's the Nevera R battery. So this is 1.5 megawatts of power, so 2,000 horsepower from this thing. And I think that's just fascinating. You know, from a physics perspective, nothing is moving. Like there's no physical, you know, nothing is actually moving in this car. You have 8,000 battery cells being discharged, and that propels the car in 1.7 seconds, 0 to 60 miles per hour. So this is a full EV battery, and the way the modules look like, they have lots of these little 18650, sorry, in this case 21700 cells, and they are cooled top and bottom by water glycol. So there is no cooling snake in between. We have some other projects where we use cooling snakes. Yeah. And the battery cells are just in this module with every module being controlled with the battery management system. So you have a bunch of these modules inside of this pack. While this is the Bugatti battery, the Tourbillon, you can see it's a lot smaller.
Yeah, because it's really slimline compared to this.
The architecture of the Tourbillon is completely different compared to the Chiron. So in the Tourbillon you would be sitting here, right? So where in the Chiron you had the gearbox in front of the engine, so you had a big gearbox between the passengers, so the passengers would sit very far from another. that also meant that the glass house was very wide. And for top speed, you know, people always talk about the aerodynamic resistance, but actually what matters as well is the frontal area.
Of course.
Yeah. So we try to reduce the frontal area, pushing the people closer together, but still, you know, it's not like you're not cramped in the car.
You're the driver here and I'm the passenger.
Exactly.
That's where we'll be.
Exactly.
Higher up.
A little bit higher up. So also, you know, the contour of the seat, like, you know, the module basically comes where your back is. So the seat starts somewhere here, right? So it fits very well within the car. And it's a very substantial battery. It's 700 kilowatts, or it can deliver 800 horsepower in the vehicle, depending on the temperature of the battery. But also 25 kilowatt hours of energy for the range of the car, which is going to be like 50, 60 kilometers, maybe even up to 80, depending on the driving style, in full electric mode. So very substantial for such a car. And what's interesting, it's completely different compared to the Nevera battery. Here we have submerged battery cooling. So this is how the module looks like inside. Similar battery cell, so the 21700 factor, so the smaller battery cells, with oil running directly over the cells. So you have a direct cooling. When you are cooling the cells directly, because obviously they are electrically active, so you can't use water directly connecting to the cell. So when you directly cool the cell, you have to use a liquid that's thermally conductive but electrically non-conductive, which in this case is oil, which makes this very difficult to seal. So you have everything pressurized under oil. So that means there is a cover that comes on top that's laser welded, but not just around. Also these pillars are connecting the top and bottom lid of the battery module, because otherwise it would fall apart of the pressure. So these pillars are distributing the stress on one side and the other to keep the module together. 6 of these modules. So the interesting thing about the Tourbillon is we have a very traditional combustion engine, you know, naturally aspirated, high revving, but a very high-tech electric powertrain, so that the electric powertrain, let's say, gives the performance that you lose by removing turbos. Yeah. But I didn't want to have turbos in the car, so this is replacing the turbos in a way.
Yeah, I know your thoughts on turbo hybrids is a case of why would you have 2 compromises? Why
exactly.
Would you not? Yeah, so you have the most high revving, crazy engine possible, and then you fill in and you have...
Exactly.
I guess the good news for non-hypercar collectors, like you and me, is that what Rimac's learned in the high-end stuff, they trickle down into tomorrow's regular EVs and hybrids.
So this is the cool stuff we do for like Bugatti, for Nevera. Here's a Valkyrie battery. That's also something I can show.
As you do.
But this is the high volume stuff that we do for BMW and other car companies. So we produce those now in hundreds of thousands of units.
So in a simplistic way, is this the stuff that sort of pays the bills to do the stuff that you're more passionate about?
That was the case in the beginning. Well, yeah. I started a company to just make cars. I just wanted to make my own car, but then I couldn't find investors. So I was like, okay, how do I pay the bills? And it was like, let's start to do anything that pays the bills. And that was, by coincidence, we started to work for other car companies. Yeah. And that kept the lights on, but like just barely surviving in the early days. And then when the Bugatti deal was happening 4 years ago, we split the company in 2. So we have the hypercar business, which is Bugatti-Rimac, and we have the tech business, which is Rimac Technology. And both companies have to be successful on their own. So Bugatti-Rimac making hypercars has to be successful and profitable, and the tech business has to be successful and profitable. And if you look at it, so the tech business now, we have 5 billion euros of ordered business from the big car companies. So that's...
that sounds successful.
Yeah, well, the margins are not that great by selling batteries to other car companies, but I'm happy. Like if you asked me 5 years ago if I would be happy with that, I would be very happy. So you'll see our batteries in many cars. Well, I'm sure some of the people who follow more closely, they know where our batteries are, but I can't say it, the car companies have to say it themselves.
I think we might know a few.
Yeah, a few. Actually, I would say most of the high performance cars have our batteries, or like premium cars. Then on the other side, the Bugatti-Rimac business, Bugatti is completely sold out. Basically until the end of the decade, we have every car sold. You can't come no matter how much money you have, if you come to us and want a Tourbillon now, there is none.
Well, this is devastating. I was going to get my order in any day now.
Yeah, so...
Wow, just all Tourbillons gone.
Yeah. Well,
congratulations.
Already a year ago. Yeah. Basically, when we presented, just a year ago, we presented the car. Yeah. At that time, it was already all gone. So, both companies have the fundamentals. And if you have the executives from car companies, just yesterday there was one here, they're coming here and like every one of them says the same thing. Like in the auto industry, it's doomsday, everyone's depressed and like letting people go and reducing factories. In our case, it's the other way around. Like we are, enthusiastic, we are growing, we are hiring, we are building new factories. So despite the industry not being in best shape, I think both the companies in our case are doing very well.
Industry forecasting over, Mate got back to his hobby of showcasing just how much performance he can wring out of an e-motor.
And this car basically uses the tires to the absolute optimum and last, Newton meter they can transfer in acceleration. Yeah. And this is the only car, I think, in the world that accelerates faster than it brakes. Because you have wider tires in the rear and more weight in the rear, and you have super precise control of every wheel because you can control it at least 100 times per second when you accelerate with traction control and with launch control. So you have super precise control, and like ideal acceleration is not at 0 slip, it's at like 7-8% of slip. And we can get exactly 7-8% of slip with these electric motors. And then when you brake, the front tires, which are smaller, are more loaded, and ABS has lower control than electric motors, so you are not braking as fast as you accelerate. Yeah.
So it's worse accelerating is more violent than doing an emergency stop.
Exactly.
In a Nevera.
Up until like 100 miles per hour, it's that way.
Yeah, I can vouch for that, having driven it yesterday.
It's brutal.
Just about recovered.
I mean, the car is brutal when you drive it.
And it turns out you'll be able to own your very own bit of Tourbillon motor in a regular family car pretty soon.
So this is just an interesting example how technology from Rimac trickles down. So this is the front powertrain of the Bugatti Tourbillon, super high performance, super compact. But this is the same architecture, just scaled a bit differently for a rear powertrain of a SUV and sedan car that's going to be mass manufactured for another car company. So we scaled this from a hypercar to a family car, SUV kind of thing. And that's what we are also about, like trying to help other car companies make exciting and cool hybrid and electric cars by developing the tech first for hypercars and then applying it elsewhere. And these things will be produced in hundreds of units, these things in the tens of thousands, but it's the same people behind it, it's the same tech.
Yeah.
So there you go. You'll be able to own your very own piece of Bugatti in a regular family car soon. For now, let's end on Mate's daily drivers.
Okay, last but not least, in this room soon will be a battery production line, but in the meantime, Mate's found a different use for it. Come and have a look in here. Welcome to Mate Rimac's Garage of Toys. Talk us through stuff. I know you're a big CSL fan. You have a beauty car that you keep nice, and then you have one to beat on. Which one's this?
This one is the one we use. So
it looks minty.
It's not just me using these cars. I don't have a lot of time. I'm working a lot, traveling a lot. So actually all my friends can use these cars as they like. So most of the time I don't know where the cars are. Many of the employees, when they get married or they have a wedding to go to or something, they ask me to use the car. So I just give it to them. And some of the cars, are here just because I really wanted it as a kid, like the Z4M. That was the first car I bought when I started to build a collection, or the R32 Golf. Of course, the iconic E30. And
you still need to put a V10 in one of these, don't you?
Absolutely.
That's your baby project.
Maybe not in one like that to not destroy it, of course. But maybe some guys don't realize, and I didn't realize that myself, these iconic cars, when you look at them and you think, wow, these are amazing cars and so on, but from today's perspective, they are so slow. Like
So you're used to 2,000 horsepower?
But I think even someone who just drives a normal car today, like I don't know, 1 Series BMW.
Yeah, no, I drove an E30 earlier this year.
It's really slow.
Astounded how slow it was.
Right?
Yeah.
And it's wobbly and everything is wobbling around, and like you turn the steering wheel like this, nothing really happens.
The steering column just flexes.
Yeah. And you ask yourself, how was that a sports car just like 30 years ago?
That was the pinnacle of a sports saloon.
Yeah, crazy.
Yeah.
So I think it's a beautiful car, really iconic, but if you put a V10 in it, then it does something cool.
We're going to be about to drive that RS 4 litre.
That's actually not mine. Some people store their cars here, like friends, so,
okay,
but a cool car.
But the Carrera GT and the number plate.
Yeah, I mean, that's the sound of the car, right? When you drive, it's like whoop, whoop.
That is stunning.
So there is no, I think, complete car collection without the Carrera GT, and I just love it for the analog feel. And people call it a widowmaker, but I really push that car very hard with the old tires and the new tires, and I don't feel that at all. I rather feel that the car is somewhat understeery and a bit too soft.
I wish the Carrera GT was spikier, said no one ever.
Yeah, so I don't feel dangerous, that car is dangerous at all. Then the Golf GTI is a friend's car, but the SLR, we talked about it, it's not great for driving, but it's beautiful to look at. And just like as an engineering exercise, like when you drive that car and you stop, and the heat from that engine goes out, like you just look at all the chimneys in the car and like all the openings, it's not there for show, you really see it's there for a reason.
Yeah, you've got 2 members of the original Holy Trinity, so now you need an Enzo.
Yeah,
completely.
Exactly. But that's crazy, like when you drive the SLR and the Carrera GT, you think, how were these cars coming out at the same time, being in the same category and costing the same amount of money? Yeah. And now today, like, so both of them costed like 280,000, I think, when they came out. No, sorry, 400,000 when they came out. And today an SLR is like 300,000, while the Carrera GT is 1.5 million. Yeah.
I mean, I think there'll be a lot of people delighted that their car is in the sort of Rimac's collection. One that won't be is the Valkyrie. Is this something you drive?
Yeah, so I also want to buy one of every car that has our tech in it. That's an expensive hobby.
You're going to need a really big garage, the way this thing's going.
So it's the Valkyrie. I mean, I don't have a Koenigsegg Regera because that has our hybrid powertrain in it as well.
Come on, Christian, sort the man out.
One day, Christian, I'll have one for sure. Maybe also some other one. I really respect Koenigsegg and Pagani. And of course the Pininfarina Battista, which is built on the Nevera platform. Yeah, so some of the cars are there because they have our stuff in there. Yeah. And yeah, lots of more will come soon.
SF90 for a bit of benchmarking. Yeah, thank you so much for showing us around here. This is awesome. And thank you for taking us around the whole building, your brainchild. It's amazing now. I can't wait to see what it's turning out in the next few years.
That's the thing, when you were here a few years ago, which you haven't been, but many people were here a few years ago, and today they wouldn't recognize this place. And now when you will come back in a few years, which I hope you will, you'll see a completely different place. So yeah, look forward to that.
Yeah, well, I'm sure everyone's loved that. Mate, thanks so much for your time.
Thank you, Ollie.
All the best.
It was great.